Hi everyone! Today we are going to finish up our solving quadratics unit by looking at our last method, solving by square roots. So our goal today is to watch this video, complete the notes and practice, and then submit this to Schoology and check the key. So we just finished learning how to solve a quadratic equation that's in the form ax squared plus bx plus c equals 0. We've done that through factoring and the quadratic formula. However, what if we do not have a quadratic equation in that form? Like the example below, x squared minus 4 equals 0. We can see the middle term, that bx, it's missing. What can we do? Does this mean that it's not solvable? That there aren't any numbers that we could put in for our variable and get it to equal 0? Well, we're going to be focusing on this type of problem today. Below, we're first going to start looking at how to solve for a variable with an exponent of 1. This is something we reviewed at the beginning of the year in first semester. Let's start looking at example 1. We have 4x plus 3 equals 23. Well, to start off, I have to figure out how to isolate or get x by itself. So what I would do is I would subtract 3 from both sides because my goal is to cancel out that positive 3. So we would have 4x equals 20. And then our next step would be to divide by 4. And that way we get x as 5. Is it starting to come back? Okay, go ahead and pause the video right here and go ahead and do numbers 2 and 3 and check your answers with me. Did you get the same answers that I did? Number 2 is similar to number 1, so you should have gotten y equals 11. Now with number 3, be careful. Remember, we have to subtract 8. It's a positive 8, so we have to subtract 8. And then don't forget that's a negative 5, not just 5 in front of the v. So you should get v equals 6. Okay, now let's take a step back and review what it looks like to include a number squared in our equation. So let's look at number 4. We have 3 squared equals n. Now, n is already by itself, but we can do the operation 3 squared. That's 3 times 3, so that's 9. So really, it's not too difficult to solve for the variable here. We get n equals 9. Looking at number 5, okay, so now we're doing negative 3 squared. The parentheses are around the whole negative 3. It's not on the outside, so we're saying negative 3 times negative 3. Well, that is also 9. Interesting how we have the same answer for both of these. 3 squared as well as a negative 3 squared is 9. This idea is going to come back later on today too. All right, you try the last example now. Pause the video here. Did you end up getting 64? You should have, because remember, a negative times a negative, right? Negative 8 times negative 8 is a positive number. Now let's look at applying these similar ideas we just went over to solve for a variable where the variable now has the exponent of 2. So looking at number 7, how do I get j by itself? It has that little 2 next to it. It has that squared symbol. So we have to start thinking about what's the opposite operation, or what I like to say is what's the inverse of squaring a number. Just like addition and subtraction, those are inverse operations. Multiplication and division. What's the inverse of squaring? Whoa, we're really throwing it back. Guess what? It's square root. So we're going to take the square root of j squared, because these operations cancel out and I'll be left with j. But wait a minute, I can't just take the square root of one side. I have to do it to both sides. Now, if you put in your calculator square root of 16, you will get 4. But remember this idea that we looked at in numbers 4 and 5 above? Remember this idea of how a negative number squared could also equal 9, right? 3 squared and negative 3 squared is 9. We're going to use that same idea here and looking at taking the square root. The square root of 16 will be 4, but we have to consider the negative numbers as well. Because what's negative 4 times negative 4? That's a positive 16, right? So we're actually going to have 2 results here. We're going to have 4 and negative 4. Whoa, whoa. Now, sometimes I like to use this symbol. Instead of writing 4 and -4, I like to use this plus or minus 4. That means the same thing as above. So you could use either one. Let's go ahead and try number 8. Okay, b squared equals 50. Well, we just learned we use the square root symbol to do the opposite operation or the inverse of squaring. So I take that to both sides. So I know that the square root and squared, they cancel out their opposite operation, so I'm just left with b. But wait a minute, square root of 50, that's not a pretty number. So we have to work on breaking down the radicals. Oh, so we have to figure out, okay, what numbers, specifically perfect square numbers, maybe referring back to your yellow sheet, what two numbers will multiply to 50? So when I'm thinking about this, I think 25 and 2. 25 is a perfect square number. That's like me saying, okay, what's the square root of 25 times the square root of 2? Well, we can't take the square root of 2, but we can take the square root of 25, and that's 5. But remember this idea of how we have to have a positive and negative form? We got to make sure that's a positive and negative 5, but also include that square root. Interesting. So that's going to be our result right there. Perfect. All right, let's keep going. Let's go ahead and look at number 9. Okay, so we know the drill. To isolate g, to get it by itself, we have to do the inverse operation of squaring, which is square root. We apply that to both sides. We know squared and square root cancel out, so we're left with g. Now, go ahead and try to put this in your calculator. I know you're probably thinking, well, I know the square root of 25, but this is different. This is a negative 25. I want you to go ahead and test it in your calculator right now. Take the square root of negative 25. What's happening? What type of answer do you get in your calculator? Do you get an error? Do you get something that says it's not a real number? Because that's what should happen. We're not able to take the square root of a negative number. We could take the square root and have a negative number result, like a number 7 and number 8, but the negative can't be under the square root sign already. So really here, we're not able to have an answer. It's actually no real solutions. No real solutions. Now, solutions means, there's not a number that's able to put into there that makes that equation work. And remember the word real. We're referring back to the real number system. That's what we talked about earlier in the year. All the numbers that you know in existence. That's what we mean by real numbers. They can be whole numbers, decimals, fractions, you name it. When you approach Algebra 2 class, you'll be learning about imaginary numbers. But for right now, you don't know any real numbers that would work in this case. Now, I'm going to have you go ahead and try 10, 11, and 12. 12 is going to be very interesting. I'm looking forward to seeing what you get as a result for that. But go ahead and pause the video here. You try these problems yourself, and then we can go ahead and come back and talk about them. All right, let's check our answers. For 10, we should have got no real solutions because there's a negative under the square root sign. For 11, you would have gotten a positive square root of 24 and a negative square root of 24, but we have to break down square root of 24, right? We want to keep it in simplest radical form. We really don't want to work with decimals currently. We want an exact number. So I broke down 24 as 4 times 6, so it's the square root of 4 times the square root of 6. I chose this because 4 is the largest perfect square possible. Nothing else that's a perfect square multiplies into 24 that is larger than 4. So when I took the square root of 4, I got 2. Can't take the square root of 6, because all that it multiplies into is, square root of 2 times square root of 3. Can't do either of those. So that's why our answer is a positive or negative 2 square root of 6. Now for 12, we actually have a solution. But there's only one possible solution. Whenever we take the square root of 0, you only have 0. 0 is not a positive or negative number. It is essentially a neutral number. So looking at all these problems, working with square roots, when a variable has an exponent of 2, we can see there can be 2 solutions, a positive and negative number. We can see there can be no real solutions. And we can also see that there's one possible solution, but that is only going to work with when you have your variable equaling 0. Square root of 100. Let's go ahead and turn to the next page. So we're going to go back to that initial problem that we came up with that was highlighted in blue in the front page. It was x squared minus 4 equals 0. So since we can't use factoring to help us in solving, well, could we use the quadratic formula? I mean, we could. There is an a value, there's a c value, we would put in b as 0, but this is actually quite time consuming. You really only want to use the quadratic formula if there's no other way. If you can't use the way that we're going to learn, called square roots, if you can't use factoring, that's the automatic go-to. So we're going to look at a faster way to approach this problem called square roots, using square roots. So I have the steps right next to us. I'm going to go through each piece by piece. So let me go ahead and write down our initial problem of x squared minus 4 equals 0. So for step 1, we want to isolate the squared term. Now, in this problem, we only have x squared, but in future problems, we might have x plus or minus a number inside the parentheses before squaring. These are trickier problems, so we're going to have to be very careful when we're approaching them. But in this case, it's very simple. So how do we isolate x squared so it's by itself on the left side? Well, that means we're going to add 4 to both sides. So now I have x squared equals 4. Beautiful. All right, step 2. We have to take the square root of both sides, right, to undo the squared operation, the inverse of it. So I'm going to take the square root. I'm going to take the square root. Then our next step, step 3, means we have to consider, remember, both the positive and negative answer, right? We know that we're going to have a positive 2 and a negative 2 for when we take the square root of 4. Like I said, I like to use the plus or minus symbol. You can put them next to each other. Either way works. All right, and then step 4 is if there is anything else that we need to do. Sometimes there are different steps that we'll have to go through, but in this case, this problem, we don't have it here. There's nothing else that we can do, but we might see this in future problems, just not in this one right now. So looking at our answer, we know our x value can be a positive 2 or a negative 2. Now, if you want to check your answer, kind of like the last problems, just to make sure that you got the correct result, you could always plug it back into the original problem, but I'm not requiring that here, but just to let you know, you could always do that on your own time. All right, now let's try going through some of the steps below, and don't worry, we'll see a step 4 as well. No worries, but we're probably going to see that in the later problems, like maybe number 16, 17, or 18. So let's start with number 13. K squared minus 80 equals 1. Okay, how do I isolate my variable term, right? My k squared. Well, to isolate that, I would probably add 80, since that's the opposite of subtracting 80. Boom. Okay, so I got k squared equals 81. All right, next step. Take the square root of both sides. Take the square root of k squared, take the square root of 81. And then step 3 is, okay, I actually take the square root, I get k, and we have to consider both the positive and negative answer. We take the square root of 81, that's going to be a positive and negative 9. There's nothing else that we need to do here because k is by itself, so that's our answer. Let's go ahead and look at 14. All right, well, how do we isolate our variable squared? How do we isolate x squared? We're not adding or subtracting anything. We're actually going to divide. So we're dividing because, you know, it's 3 times x squared. Okay. So now we have x squared equals, I'll help you out. I'll be your human calculator. 75 divided by 3 is 25. And then last but not least, we take the square root to cancel out the squaring operation. And we're going to get a positive and negative 5. Don't forget that symbol. All right. I know I'm giving you a little bit of a challenge, but I want you to try 15 right now. It took ideas both in 13 and 14, combine them together. I'm going to see what you can do with this problem. Pause the video right here. Let's try walking through this problem together now. Okay, which operation do I do first? Do I work with the 8? Do I work with the 2? Your life is going to be a lot easier if you're working with that 8, so I'm going to subtract that 8 first. So 136 minus 8, we end up getting 128. So 2m squared equals 128. Now let's divide 128 by 2. We end up getting m squared equals 64. All right, and then last but not least, we take our square root. So we have m equals a positive or negative 8, since that's a square root of 64. Good deal. All right, we got a couple more problems, and then you're going to be on your way to practicing using square roots. Now, let's take it a step up. All right, here we go. Now, on 16, we can see that there's something inside the parentheses besides x, besides our variable. This is tricky. That squared holds everything together. It does. A lot of you are already starting to think about, okay, well, when I have that squared, that means I write this down twice. Yes, exactly. But in this case, we're not going to use that process of distributing or factoring. We're going to try something a little bit different. Now, looking up at step 1, our usual step 1 is to get x squared by itself, but we can also look at and see we can have x plus or minus a number within that squared part. We can have that together, and that's still isolated. So right now, it actually is completely isolated. Then the next step is take the square root of both sides. Whoa. Well, we can do that. Everything here is squared. So to undo and to kind of get to that 9, we have to do the square root of x minus 9, that whole quantity squared. We can't touch that 9. It's kind of like, under an umbrella. It's all there together, and we have to take the square root first before we can touch it. So I take the square root of both sides. Remember, these cancel. I may not have shown that on all the other problems, but they do cancel, squared and square root. Just keep that in mind. So what's left is x minus 9. I can't have the parentheses. I don't have to. It's not being multiplied by anything. I'm just subtracting, x minus 9. And then, this is the tricky part. Remember when we took the square root of a number before? We have a positive and a negative number. So it's a positive and negative 7. This is where step 4 is coming into play. It's a little tricky, right? We now have to undo any remaining operations to solve for our 2 solutions. So looking at this, x minus 9 equals positive or minus 7. Here's what I have to do, and this is kind of tricky. I have to get x by itself, so I have to add 9 to both sides. This is the tricky part. So if anything is your key takeaway, pay attention here. This is where I've seen a lot of students mess up. We know these cancel out, right? So we have x on the left side. And then, remember how we have that plus or minus symbol? That only goes with the 7. The 9 is always positive here, but we have a plus or minus 7. That means we're going to split our answer up in 2 ways, right? We're going to have 2 solutions. So we're going to have 9 plus 7, and we're going to have x equals 9 minus 7. So x will equal 16, and x will equal 2. Let's try our next problem then. Okay, here we go. Now, the tough part here is that, there's a 6 in front of, our variable plus a number squared. A lot of you are going to have this urge to want to distribute. Yeah, distribute that 6. No. This is your other key takeaway from this video. Don't do that. Fight the urge to do that. Remember that r plus 7, that whole thing is squared. You have to undo that squared part before you can work with the 7. So we're really referencing back to step 1. We have to isolate kind of that squared term. So what we're going to do is we're going to divide the left side by 6, since we're multiplying by 6. That's the opposite operation. So that way we'll be left with r plus 7, that whole quantity squared. Now I got to do it to the right side. So 600 divided by 6, that's 100. Perfect. This looks familiar. This looks exactly like where 16 was at before. So now we have to undo the squaring with square root. We do that to both sides, so that way, boom, those cancel. We're left with r plus 7 equals, and then we have to take the square root of 100. Now, that's 10, but remember, it's a plus or minus 10, right? It's plus or minus 10. Do not forget about that. I'm putting them in yellow, so that way we can kind of remember that. So now we got to get r by itself. Well, I have to subtract 7 to both sides, so we're left with r equals, and it's going to be a negative 7. Remember, it's plus or minus that 10. That doesn't change at all. Keep that in mind. So now we can split it up into two parts like the problem before. So we have r equals negative 7 plus 10. So that will be 3. And then we can do r equals negative 7 minus 10. So that will be negative 17. Put too many 7s in there. All right. Go ahead and pause the video right here. And I want you to now try number 18. All right, did you go ahead and get what I got? X equals 14 and x equals negative 8. All right, nice job. I think we're ready to move on to some practice on our own. Okay, here are a few practice problems for you to try on your own. Go ahead, once you're done with these, submit these and your notes to Schoology before you can check the answer key. You got about 9 problems. You're seeing all types of varieties. Now, one thing I do want to point out is number 27. Don't be tricked by that negative in front of x plus 2. Remember, if we don't have a number there, think of what number we can write. Like if I just had, a normal letter A, I could say 1A. Or if I had a negative A, I could say negative 1A. So just keep that in mind as you're working through these problems.